In this video, we're going to talk about 2.6 Objective 1, where we find common denominators. This is going to be an important skill in being able to add fractions with unlike denominators when we get there. And the best way that I know to show you how to do this is with prime factorization. So I'm using the whiteboard over here to have plenty of space to do that. So the denominators here in these fractions that we have for problem number 1 are 5 and 4. If I find the prime factorization of 5, it's already 5. And the prime factorization for 4 is 2 times 2, or 2 to the second power. My least common denominator, that I'll abbreviate LCD, is going to have to be made up of 2's and 5's, because those are the factors that I see represented. I have to use all the factors, all the bases that I see represented. This is called a base, and this is called an exponent. The little number up top is called an exponent. And I need to be greedy, and I need to take the most that I can. So if I had 2's in both places, I would take from the number that has the most 2's. Well, the most 2's that I can take from is from 4, which has 2 2's. And then from 5, I can only take 1 5. 2 times 2 is 4, times 5 is 20. And that's always going to be a common denominator if we multiply the two numbers together, but that's not always going to be the least common denominator. So let's look at number 2 as an example here, that we have 2 and we have 14, and notice that they share a common factor of 2. That's going to be important here for why I do not just take 2 times 14, but 2 is a prime number. 14 is 2 times 7. So my LCD is going to have to be made up of 2's and 7's. It does not matter which one I take my 2 from, because there's only 1 2 in both of them. And the most 7's that I can get is from choosing them from 14 is 1 7. So my LCD, 2 times 7, is going to be 14. That's what happens when you have a denominator where the other denominator, the smaller denominator, divides into the bigger denominator evenly, like 2 divides evenly into 14. So the LCD is going to be 14. Likewise, 2 divides into 6 evenly, so my common denominator here will be 6. 27 divides into 270 evenly 10 times. The common denominator will be 270. 7 divides into 77 evenly, so the common denominator will be 77. 7 and 2 have no factors in common, so they're both prime numbers, so I'm just going to multiply them together. 2 times 7 is equal to 14. So that's kind of like this first scenario up here where they had no factors in common and I just multiplied them, right? 5 times 6, no factors in common, because 6 is 2 times 3. So I'm going to go ahead and multiply 5 times 6 to get 30. 5 and 11 are both prime numbers, no factors in common. 5 times 11 is 55. 10 and 3, 10 is 2 times 5. No factors in common. So I'm going to take 10 times 3 is 30. And then 6 and 11, no factors in common. That's 2 times 3. That's a prime number 11. So 6 times 11 is 66. Let me see if I can show you an example here before we continue with things that have a common factor, but one doesn't necessarily divide into the other one evenly. So maybe something like 18 and 24. Maybe this is 5 and maybe this is 7, let's say. Okay, so 18 and 24 have a common factor of 6. This is 6 times 3, this is 6 times 4, but 18 does not divide into 24 evenly. So what happens here is this is 2 times 9 and 3 times 3. So this is 2 times 3 times 3, or 2 times 3 to the second power. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. So that's 2 times 2 times 2 times 3, or 2 to the third power times 3. My LCD here is going to have to be made up of 2's and 3's. Those are the only factors that I see represented. And so when I'm greedy, I'm going to choose my 2's from over here where I have 3 2's. And I'm going to choose my 3's from over here where I have 2 3's, because 2 is bigger than 1 and 3 is bigger than 1. 2 to the third power, 2 times 2 times 2 is going to be 2 times 2 is 4 times 2 is 8. 8 times 3 is, sorry, this was to the second power. It's 3 times 3, 8 times 9 is 72, right? 72 is my LCD. And if I were to, we'll talk more about how to make equivalent fractions using this idea, but I could look and I could say, okay, I have 1 2 and 2 3's. I need 3 2's and 2 3's, so I need 2 more 2's here, so I'd have to multiply by 4 over 4. And I have 24 is 3 2's and 1 3, and I need 3 2's and 2 3's, so I'd need to multiply this by 3 over 3 to get a denominator of 72. And I wouldn't have to think about what my unit fraction would need to be. So that'll come in handy next time when we are going to be adding fractions with unlike denominators, I believe. Let's make sure that that is what's coming up next. Yes, so we'll be talking about section 2.6, objective 2 next time, where we add fractions with unlike denominators. So see you for the next video.